So in this video, we're going to go over the fall semester final exam review. So let's get going because it's like 42 questions or something like that. So first of all, it says describe the these big bold words are the different standards that are on this test. Okay, so 3 transformations will be performed on a triangle ABC. Which set of transformations will always produce a congruent triangle? See is this phrase congruent triangle because that is relevant to what it's asking us. So always produce a congruent triangle. So obviously congruent triangles are the same shape. So rotations, translations, reflections produce the same shape. However, dilations do not. So dilations make a shape bigger or smaller. So that's why our answer is D, because it includes rotation, translation, reflection. Number 2 says, which of the following transformations to ABC would not preserve the size and shape? So once again, that's going to be a dilation, right? Okay. So number 3 says triangle ABC has vertices A, B, and C. If triangle ABC is translated using the function x minus 6 and y minus 5, and then rotated 180 degrees, what would be the coordinates of the vertices of the triangle ABCD prime? Okay, so we've got 2 transformations here, right? So we know that we're going to subtract 6 from x and subtract 5 from y to get our first prime, and then we're going to rotate 180 degrees, and the rule for that is negative x, negative y. And you guys absolutely have to know the rules. So on the next, before I go on to the next slide, I'm going to go over the rules, okay, just to remind you guys what they are. So on this one, we have 3 points, right? So I'm going to go ahead and look at my answers at this point. Notice that we have the same A and B here for C and D. So I'm not going to use A to transform, and I'm not going to transform all 3 points. I'm going to see if I can find one that's uniquely different from all of them, and that would be C. So we're going to pull our C, and that's 2, 6, and this is a test-taking strategy, y'all. So then we're going to subtract 6 and subtract 5 from that, and that's going to give us our C prime. So that's going to give us negative 4, 1, and then we're going to apply this rule next, right, to get our C double prime. So we're just going to change the signs of the 2 values, okay? So that gives us C. And again, the reason why I chose to transform C is because C is different for all 4 different choices for C, okay? Number 4 says the rectangle below is rotated 180 degrees counterclockwise. Again, this rule is negative x, comma, negative y. About the origin, which of the following ordered pairs is a vertex of the rectangle's image? So I'm going to go ahead and label these vertexes. So I got 4, 1 here. I've got 4, 5 there. I've got 1, 5 here. And then I've got 1, 1 in my left corner, okay? So what we're looking for is which of those 4 vertices, both the x and the y, changed and gave us a value that's over on the left. And that would be A, okay? Then we got number 5, trapezoid TUVW is rotated 180 degrees counterclockwise. Now remember, counterclockwise is normal, okay? So that's going to be there. So that's going to be negative y, x is our rule. About the origin, after the rotation, what is the location of V? So this time all we got to do is find V right here, right? So that's going to be 6, 2. We're going to apply that rule to it. And when we do, we move our 6 over there, and we move our 2 to here, and we negate it, okay? So that's why the answer is negative 2, 6. And I am. So we're going to go over rotations here, okay, and then we'll go over reflections over on the right, okay? So these are rotations. So if we start with our x and our y here, remember if we go 90 degrees, and that's counterclockwise, and that's normal, right? Counterclockwise is normal. Our value here would be negative yx, okay? And remember, this is also 270 degrees clockwise, right? Okay, then when we get down here, this is 180 degrees. Remember, each of these quadrants is 90 degrees. So this is just negative x, negative y. And again, that's because all the values over there in that quadrant are negative, right? And then if we keep going over to here, then we got 270 degrees counterclockwise, right? Which is 90 degrees clockwise. Okay, and here again, it's going to be y comma x, only this time the x is going to be negative, okay? Now we're going to talk about some reflections over here. So with reflections, I'm going to go ahead and label the x and y axis. Okay, so this is our y axis and this is our x axis. So again, if we start with our x, y here, and we reflect over the y axis, then it's going to be negative x comma y. Notice nothing about the y value changed there. Now, if we reflect over the x axis here, it's going to be what? It's going to be x negative y, because again, the y value changed, okay? So this is x comma negative y. Now we're also going to talk about two others. We're going to talk about a reflection across the line y equals x. So this is the line y equals x. And when we do that, they just flip, right? So it's going to be y comma x when we reflect over y equals x. And over here, here's another one. This is going to be the line y equals negative x. So this is y is equal to negative x. And this time, they're going to flip and change signs. So it's going to be negative y comma negative x. Those are all of our normal transformations, okay? All right, so this next one says, given a geometric figure and a rotation, reflection, or translation, draw the transform figure using graph paper, blah, blah. This is our standard, okay? So our question is number 6. Quadrilateral ABCD and EFGH are shown in the coordinate plane. Quadrilateral EFGH is the image. Key phrase there, image. So that means this is after, okay? So we're going to write after there, and this would be before, right? So this is our pre-image. So that means we're going from ABCD to EFGH, right? So then it asks us what sequence of transformations occurred. So let's just pick a point. So let's pick point B up here, okay? So that is the point negative 3, 7, negative 3, 7. Okay, then let's see what maps to B. So B is the second letter there, so we're going to look at F down here. So this is our F down here. And so that is now 3 comma negative 7. So what rule would be used to do that? Isn't that going to be negative x comma negative y? It is. So that's a 180-degree rotation rule. But it says, for this question, choose 2 answers. Now, guys, on the final, if it says choose 2 answers and you don't, you're going to miss the question, okay? So, if you notice, if we just had this, it would be a reflection over y. And if we just had this, it would be just a reflection over x, right? So notice point B here, B, a reflection across the y-axis, that would be negative x comma y, and then a reflection across the x-axis would be x comma negative y. So notice if we put these two changes together, we get what we just, we get what we just had. This and this, we get negative x, negative y, right? So these are connected. If you do 180-degree rotation, it's the same as the two reflections, reflection over y and x, okay? All right, part B says quadrilateral ABCD will be reflected across the x-axis. Okay, so that's going to be x comma negative y, and then rotated 90 degrees clockwise. Okay, clockwise means we're going down to the 4th quadrant, right? So that's going to be y comma negative x. About the origin, decrete quadrilateral ABCD prime, double prime, what will the coordinates of B be? So we got B up there already. So our original B was negative 3, 7, right? So we're going to use this first to get us to B prime. So that's going to be negative 3, negative 7. And then to get to B double prime, we're going to use that property, B double prime. So now we're going to move them. So we're going to make our y our x, okay? And then we're going to change the sign of the x, right? Okay, so that's why the answer is negative 7, 3. All right, number 7 says triangle ABCD is shown in the coordinate plane. Triangle XYZ is not shown. It is located in the coordinate plane with the vertices points x, y, and z. Which of the following transformation shows that the triangle ABC is congruent to triangle XYZ? So I'm going to go ahead and plot these points for XYZ. So x is 9, 0. It's right there. And y'all do know that that's the same as A double prime, right? If it was moved twice, okay? So that's my x. Then we have y is 7, 4. Wait, that was not 9, 0. Just give me a second. Having trouble today. 9, 0 is there. So that's my x. And then we got 7, 4, which is right there. That's my y. And then we have 7, 0, which is right there. And that's my z, okay? So hopefully you can pretty quickly see that there's a reflection in this, right? So wouldn't it be a reflection over the y? So I'm going to go ahead and scratch out x because I know that's not true. So let's go ahead and do that reflection. So I'm going to count from the y-axis. 1, 2, 3, 4, 5, 6, 7, and I'm going to count 1, 2, 3, 4, 5, 6, 7. So that point is there, and we go 4 up, and it's right there, okay? And then 2 over, and it's right there. So this is a reflection, right? But look, something else obviously happened. It also went 2 units down, didn't it? Okay, so that's why the answer is C. It says, is this a rotation 180 degrees about the origin or a reflection? So let's go ahead and connect our vertices. We've been doing this for a while. So let's go S to S prime and Q to Q prime. Up, what happened? They crossed, right? If they cross, remember, if they cross, it is a rotation, right? So next we have number 9. So number 9 says the vertices A, B, C are A, B, C, and if ABC is translated 1 unit down and 3 units left. I kind of like to do this because often this is going to show up like this on an exam, okay? So remember, this means y minus 1, and this means x minus 3. That's what's happening, okay? So again, let's look at our points in our answers. So D, all the D's are different. The E's are, some of the E's are the same. All the F's are different. So I'm either going to use D or F here, which would be A or C, okay? So let's just go ahead and use our A. So our A was 2, 1, okay? So we're going to subtract 3, and then we're going to subtract 1, okay? So that's going to give us our D, and so that's going to be negative 1, 0, which is D there, okay? Triangle ABC has vertices A, B, and C is rotated 90 degrees counterclockwise. That's a normal rotation, right? So that's going to be negative y comma x about the origin. Then reflected over the x-axis, this is going to be negative x comma y. What single transformation can be performed on ABC that would result in the same final image? Now for me, it's easier to do this with points for me. So I'm just going to go ahead and do this, and then I'm going to compare A to A double prime. So here, our A prime, if we applied this rule right here, is going to be 1 comma negative 1 comma 5, right? That's going to be our A prime. And then our A double prime, now we're going to apply this rule, okay, right here. So now we're going to change the sign of x, so it's going to be 1, 5. Okay, so now what we want to do is find the rule that goes from A to A double prime. Looks to me like they just switched, right? So this would be a reflection over the line y equals x, right? Because with that, the rule is they just flip positions, right? Okay, so number 11 says in original transformation, ABC and all the sides are all the lines connecting the vertices are congruent, and all the lines connecting the vertices are parallel. Which of the following transformations was applied to ABC? So if I do A, B, C here, and I do A prime, A double, or say A prime, B prime, C prime here, and we connect those vertices, okay? So we connect that to that, B to B, and C to C. Do you notice that all those lines are congruent? And that's what this means. They're congruent, right? And they're parallel. That's what this means, okay? So when the lines are both congruent and parallel, it's translation. Now, if it was a rotation, they would not have been congruent nor parallel, okay? If it had been a reflection, they would have been parallel, but they would have not been congruent, okay? So that's what you need to keep in mind, okay? Number 12 says, what combination transformations could result in the following image? So the first thing I notice is that the ABCD prime got bigger, right? So we're going to go ahead and eliminate these two answers because that says it dilated by a scale factor of 1/2, which means it would have got smaller. Okay, then we're just going to connect our vertices again. So I've got D to D prime there, and I've got C to C prime right there. They cross, so that means it's a rotation, right? So that's why the answer is C. And number 13 says the diagram shows triangle PQR in a coordinate plane. So I'm going to go ahead and redraw this on all of these and see if we can figure out which of the following graphs is a result of a reflection. Okay, so let me move it up here. So we're going to redraw this here. So that's like 1.5 high and 2 wide. Okay, 1.5 high and 2 wide. 1.5 high and 2 wide. And 1.5 high and 2 wide. Okay. So now I can tell that the first one obviously is a rotation because the shorter side, so A is a rotation, this is a rotation. How do I know that? Because this became this, okay? And then it looks like PQR might have reflected and moved, but there's no way it just reflected, okay? So for number B. And then down here, it was just a translation, right? And so this last one, can you guys tell? It is a reflection. I can. So look, from that vertices to that vertices, and from this vertices to this vertices. So yeah, all those are parallel, right? But they're not all congruent. So this is our that's our reflection. Number 12 says using informal arguments to establish facts about angle sum. Okay, so then two parallel lines are cut by a transversal. So we're going to draw as two parallel lines, and we're going to cut them by a transversal. So it says, which of the following scenarios is not a possible result? So same side interior angles would be X and Y. So those are supplementary, right? Do you notice this one's acute and this one's obtuse? All these angles are either going to be supplementary or congruent if these lines are parallel, okay? So this is true. A pair of alternate exterior angles. Okay, let's see if we can find some alternate exterior angles. So alternate exterior angles would be like A and B, and those are equal. So are these equal here? Oh, they are not. Okay, so this has got to be our answer, but let's keep going just to double check. Supplementary angles means they add up to be 180, right? So when you add up these two angles, they should equal 180, right? And these do. Okay, so that's a true statement as well. And then a pair of corresponding angles, where our B and our B right here are our corresponding angles, okay? So those are equal as well because you notice they're both obtuse angles, okay? So remember, corresponding angles are on the same side of the transversal and the same side of the parallel lines, okay? So again, our answer was B. Number 15 says find the measure of the exterior angles in the diagram. So these are our remote interior angles. So don't we have to add these two together? 30 plus 70, and that equals our X. So that means 100 would be equal to our X, okay? 100 degrees. All right, this next one's similar concept. So it says in the diagram, angle at B is 85. So let's go ahead and label that 85. And then it says E is 115. Now, hopefully you notice that these two angles form a line right there, right? You guys notice that? Those two angles form a line. So we're going to go 180 minus 115. That's going to give us angle A. That's 65. So we're going to put that 65 right there. Now the problem's saying what is the measure of angle C, okay? So we're actually looking for this one, and hopefully you remember that when you add the three angles together in a triangle, they have to equal 180, right? So we're going to add the 65 plus the 85. That's going to give us 150, and then we're going to subtract that from 180, okay? And that's going to give us our angle C. So that's going to be 30 degrees, right? So that's our answer. C is 30 degrees, okay? All right, in this next one, it says in the diagram, lines M and N are parallel. So I'm going to draw some parallel symbols on those lines, okay? And then it says, what is the measure of W? So we're trying to find something that is, let me move that out a little more. Parallel, okay? Trying to find a relationship in here that's going to help us solve for W. So I noticed that this angle up here is 35 degrees and W is down there. Those are alternate exterior angles. And so that's why the measure of W is 35 degrees. Okay, then it says, what's the value of X? Okay, so notice we have these two angles right here that form a straight line, right? So we're going to add those together, 3x plus 6x. That's going to be equal to 180 because the measure of a line is 180. So this is going to be 9x equals 180. Divide both sides by 9. So x is equal to 20. So that's why the answer is D there. All right, again, the angle measures in triangle, 2x plus 3 degrees, 9y minus 7 degrees, 7y plus 4 degrees. Which of the following is not one of the angles? You guys got to catch those words on this test, okay? Be very, very careful because otherwise you're going to choose a correct answer when it's asking you really for an incorrect answer. So remember, when we add three angles together in a triangle, they have to equal 180. So we're going to do 2y plus 3 plus 9y minus 7 plus 7y plus 4, and all of that's got to equal 180. So we're going to combine our like terms. We're going to combine the 2, the 9, and the 7. So that's going to be 18y. And then 3 minus 7 plus 4. 3 plus 4 is 7, and minus 7 is 0 then, right? So this is going to be 18y is equal to 180. We're going to divide both sides by 18. So that's going to give us 10. So now we have to plug that 10 back in to all three to find out which one of those answers is incorrect, right? So we're going to go 2 times 10, that's 20, plus 3. So this one's 23, right? So that one checks out. Okay, let's do this next one. 9 times 10, that's 90, minus 7 is going to be 83, right? So there's our 83. And our last one over here is going to be 7. Let's do it in a different color. 7, maybe. 7 times 10, that's 70, plus 4 is 74, right? So there's our 74. So this is our correct answer because it's asking for the one that's not a measure. All right, number 19 says line P is parallel to line Q as shown in the diagram. So once again, these are parallel. So then we have our relationships, right, that exist amongst these angles. It says, which of the following pairs of angles are corresponding angles? So let's look at 1 and 7. So these are same side of the transversal, right? So these are same side exterior angles, right? Okay. And then 4 and 6, those are same side interior. Then we have 3 and 7. No, sorry, 3 and 7 was the last one. Let's look at 1 and 3. 1 and 3, those are vertical, or a linear pair. Sorry, these are a linear pair. And then our final one would be, I said 3 and 7. Then these are our corresponding angles, right? They're on the same side of the transversal, and they're on the same side of the parallel line. Same. All right, so number 20 says line AI and GJ, these are parallel, these lines. Which of the following transformations would prove the corresponding angles EBI, so we're talking about this angle, and BCJ, so we're talking about that angle, BCJ. So it's asking us what of these statements could prove that? So a translation of line GJ by a directed line segment CB. So if we move this line up to there by that directed line segment CB, then yes, we would get that angle, wouldn't we? So that's our answer right there. If BF is moving it down, so that would not be true. A rotation would move these points on opposite sides, so it would move the angles to other sides, guys. So that's not going to be true either. So, all right, so number 21 says using the figure at the right, if angle 2 and what is the measure of angle 4? Okay, so the only thing that's missing in this drawing that should be there, y'all, is that these are parallel, okay? So it should say that somewhere. And so basically what we're looking at is angle 2 and 4. 2 and 4, these are corresponding angles, which means they are equal, right? Okay, so we're going to say 2x plus 18 equals 5x plus 9. I'm going to subtract the 2x from both sides. That gives me 3x over here. I'm going to subtract the 9 from both sides. That gives me 9. So x is equal to 3. So now we have to plug that 3 back into this equation, 5x plus 9, right? So we're going to say 5 times 3, that's 15, plus 9 is 24, right? So this angle is 24 degrees, okay? So the next one says if angle 6 is 3x plus 19 and angle 7, 6 and 7. Now notice these are not the same shape. One's acute, one's obtuse. So these are same side interior angles. So I'm going to write same side interior. And these are supplementary, okay? So I'm going to write 180, okay? So when I add these two angles together, the 3x plus 19 plus 12x plus 11, I'm going to set them equal to 180, okay? So 3x plus 12x is 15x. 19 plus 11 is 30. So I'm going to subtract 30 from 180. So that's going to be 15x equals 150. And then x is going to be equal to 10 here. Okay, so we're going to plug that 10 back in for angle 7. So angle 7 would be 12 times 10, that's 120, plus 11, so that's going to be 131, right? Okay. All All right, our next one, it says if angle 2 is 7x minus 3 and angle 6. So 2 and 6, 2 and 6, 2 and 6 are right here. So these are alternate interior angles. And those are congruent. Again, look at them. They both have acute angles, right? So they're going to be equal. So once again, we're going to set these equal to each other. 7x minus 3 is equal to 2x plus 17. I'm going to subtract the 2x from both sides. That's going to give me 5x here. I'm going to add the 3 to both sides. That's going to give me 20. And 5 goes into 20 4 times. So x is equal to 4. And this time it's asking us for a measure of angle 2. So we're going to go 7 times 4. That's 28 minus 3. So this one is 25 degrees. Okay? All right. So the next one says if angle 3, I'm going to go back to our blue here. If angle 3 is 9x minus 7 and angle 5 is 3x plus 77, what is the measure of angle 6? So 3 and 5 are vertical angles. So these are vertical angles. And that means they're equal, right? So we're going to set those two equations equal to each other. Now, it's actually asking us for 6. So we're going to use the property of a linear pair to solve for 6. But right now, we're just going to solve for x. So we're going to do 9x minus 7 equals 3x plus 77. Subtract 3x from both sides. So that's going to give me 6x on the left. And then we're going to add 7 to both sides. That's going to give me 84. And then 6 goes into 84 14 times. So x is equal to 14. So now I'm going to find, it doesn't matter which one I find, but do you notice that these two form a line right there, 6 and 3. So I'm going to go ahead and plug that back in for 3. So 9 times 14 minus 7 is going to give me 119. Okay, so now when I'm looking for angle 6, I got to subtract 3 from 180, right? So 180 minus 119 is going to be equal to 61 degrees. So that's our answer there. Okay. All right. The next one says use the transformations to answer the following questions. A triangle is at most one obtuse angle. So we know we're talking about angles here, okay? So Eduardo is proving the theorem above by contradiction. He begins by assuming that triangle ABC, angle A and angle B are both obtuse, okay? So if he does that, this says if two triangles are equal, the sides are opposite, the angles are equal. So, okay, so that's not going to really help us. If two supplementary angles are equal, then the angles in each measure are 90. Two supplementary angles are equal. That's not a guaranteed statement, number 2. Okay, so that's not going to be our answer. The sum of the measures of angles of a triangle is 180. That is true, and that is going to help us solve this problem. Okay, but then the last one says the largest angle in a triangle is opposite the largest side. That doesn't help us at all again. So, because we're not really talking about sides, okay? So that's why the answer is C. Number 26, which of the following methods would not be used to prove that two triangles are congruent? Prove all 3 sets of corresponding sides are congruent. Okay, this is true. That's side, 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 right? So that's a true one. Remember, this is a not statement. Prove all 3 sets of corresponding angles are congruent. Now remember, angles don't prove anything, right? So even if we had angle, 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 if the sides dilated, the angles would stay the same, but the sides would not, right? So I think our answer is going to be B, but let's keep going. Prove that 2 sides and an included angle. That would be side, angle, side. Yep, that's one of our methods. And then prove that 2 angles included side. So this would be angle, side, angle. So all of those are methods except for B, for proving congruence. Now, angle, angle is what we use to prove similarity. Okay. Number 24 says which parts must be congruent to prove that PQR is congruent to PSR by side, angle, side. So we know that we have the shared side here. So we need a side with an angle between it. So if we look at Q and S, if that was our angles, then it would have to be QR and RS, and that's not the case here, right? Then if we do Q and S again, we have QR and SR. QR and SR. But again, that's not the right side, right? Because it would have to, okay. So look here, if we had these sides, guys, it would be angle, side, side, right? So that's why this can't work, okay? So The next one says, and I'm going to erase what I had on here just so we can keep going. QRP, QRP, so that's that angle and this angle, okay? And then it says QP, okay, so this would be side angle again, side angle again, yeah, so this is not going to work either, okay? So let's look at this last one. Hopefully it works. We'll see. I'm going to mark our shared side again. Okay, so this one says QPR. So that's this angle up here is congruent with SPR. That's that angle up there. So these two angles would be, so now we need this side. That would mean we would need by side angle side. This side is congruent with this side. Is that what we have? QP and SP. Yep, that's the answer. D right there. Okay. All right, number 28 says, given ABCD is a parallelogram, prove that AB, yeah, I don't know where those lines went from where they were supposed to be, y'all, but we're going to work through this. ABCD is a parallelogram, so we're going to name this ABCD. This is our parallelogram, okay? See if I can clean it up just a little bit. It says AB is parallel to CD. AB is parallel to CD. That's true, right? And AD is parallel to BC, okay? Then it says angle ABD. ABD. Okay, so that means we've got this, diagonal, right? ABD is up there. And it says it's congruent with CDB. CDB is down here. So why are those angles congruent? Alternate interior angles theorem, right? Now this one was wrong on the key, by the way, y'all, okay? So, and then it says BD is congruent to BD. Well, that's true because that's a shared side, right? Oh, and then we had some other angles, so let's go ahead and do that. ADB, so that's this angle is congruent with CBD, so that's that angle there, okay? So then it says, why are the triangles congruent? Look at, what do we have up here? Angle, side, angle, right? So this is also D, okay? It says, state the theorem postulate used to prove the triangles are congruent. Let's click on the side that's shared. So this is going to be angle, side, isn't it? Number 30 says, state which postulate or theorem is used to prove the triangles. Again, click, mark the shared side. Okay, so we notice that this is our hypotenuse, right? And our hypotenuse, and then we have another leg, don't we? So this is HL. Now, again, don't assume that it's HL just because there's a right angle, okay? 31 says, complete reason for in the proof below. So it says AB is congruent with BC. AB is congruent with BC. We do have a shared side, don't we? And that BD bisects angle ABD. So that means these angles are going to be congruent right here, okay? And, okay, so all that given information is there. It says ABD is congruent. CBD, that's definition of bisect. DB is, okay, so why is this triangle congruent with the one below? So isn't that going to be side, angle, side? Indeed, it is. Okay. All right, use the diagram to answer the following questions. Which of the following statements about the triangles is true? Select all that apply. There's not enough information to prove. Okay, so let's just mark the shared side first, okay, because that's always going to be true. Then it says triangle AB. You know what? Let's just write a congruent statement. So we got the angle, then we go across the one tick side, and then so ABC is congruent to what? So we're going to start with D, and then we went across the tick side, one tick side, so that's DCB, right? Okay, so now ABC, DCB. So we know this one's not going to be true because that's the wrong statement. All the rest of them have ABC, so we got to have the statement DCB, okay? So this one's also not going to be true. So then we're just looking at what reasons are they congruent, right? So I can see side, side, side. Can you guys see side, side, side? So we've got a side here, we got a side here, we got a side here. So that's got to be one of the reasons why they are. So side, side, side here. And it's ABC and DCB, so that's one of them. Remember, if it says select all that apply, to get the question right, you got to choose all the correct answers, okay? So then also, we have side, angle, side. We do. Okay, so side, angle, side. And angle, angle does not prove congruence, y'all, so that's not going to be one either, okay? It only proves similarity. And so then the last one is going to be side angle side. It's going to be E. Okay. All right. This one, 33, says in the coordinate plane, line P has a slope of 1/3 and a y-intercept. So if we were to draw this, 1/3, so we have a 0, 2 point right here, right? Okay, so that's where it's intersecting the y-axis, and then it has a slope of 1/3. So you go up 1 over 1, 2, 3. Okay, so this would be our other point, and this would be kind of like the line. Okay, it says what is the slope and y-intercept if it is dilated by a scale factor of 3, right? So here's the deal, guys. The slope does not change. So these cannot be the answer because the slope doesn't change. But the y-intercept would change. So what we want to do is take this point right here and we want to dilate it by 3x, 3y, okay? See where it says the dilation point over here, y'all? Dilated, oh my goodness, it's not clicking. Dilated by a factor of 3. So we're doing 3x, 3y to the y-intercept, okay? So we're going to do that to this point right here. So obviously 3 times 0 is still 0, and 3 times 2 is 6. So this is our new y-intercept. So that is not the answer either. So B is the answer. All right, on this last one, it says triangle PQR is similar to triangle VWX. What is the length of PR? Okay, so that means PQ goes over VW, right? PQ, VW. So I'm going to go 54 over 18, and that's going to be, we're looking for PR, right? So that's going to be equal to PR over what? VX. So we're going to say PR over VX was 15, right? We're going to cross multiply here. So this is going to be 18 PR is equal to 54 times 15. PR, and that's going to be 54 times 15 is 810. Divide both sides by 18. So PR is going to be equal to 45. All right, so our next one says use the properties of similarity transformation to establish angle-angle criterion for two triangles to be similar. In triangle ABC, A is 65 and B is 30. So we're going to find the third angle in all of these, and then we're going to see which ones match, okay? So that's the way we're going to approach this. So we're going to add 65 plus 30. That's going to give us 95, right? And then we're going to subtract that 95 from 180. 180 minus 95, that equals 85, right? Okay. So we're going to do that for all of them. So we're going to add 65 and 30 again. So we know that this one is the same, right? 65 and 30 is still 95. Subtract 95 and we get 85 again. So I know that these two are similar, right? A, B, C, and D, E, G. Okay, so let's keep going. 65 and 95. 65 plus 95 is equal to 160. Subtract that from 180. And that's 20, right? Okay. So 65, 95, 20, that doesn't match ABC because it's asking us which one's similar with ABC. Okay, so let's keep going. 65 plus 85 is going to be equal to 150. 180 minus 150 is equal to 30. It looks to me like this is going to be another one that matches, y'all, because we have the 65, 65, we have the 85, and we have the 30 and the 30, okay? So there's another one. So we know this one does and this one does. Let's keep going. 30 plus 85, whoops. 30 plus 85, whoops. Jeez, I'm having trouble. 30 plus 85, isn't that going to be 115? So 115 from 180, 180 minus 115 equals 65. Okay, so here again, we got 30, 85, and 65. So again, 30, 85 was there, and 65. So there's another one. All right, then we got 30 and 95. 30 and 95, 30 plus 95. I'm not going to change color again, y'all. So this is going to be 125. 180 minus 125 is equal to 55. Well, that one definitely isn't because we didn't have 55 degrees yet, okay? So that means we're looking for 1, 3, and 4. So 1, 3, and 4 is answer C, isn't it? Okay. Joey built a model sailboat that is similar to his real sailboat. The triangular sail on his real boat has a base of 25 feet, so 25 feet, and a height of 12 in, wait, what did it say? Base of 25 feet. Oh, okay, so we don't know the height of the other one. So I'm gonna go ahead and just leave it like that. Okay, then we have the model, which it says is the base. So the height of the sail on his model boat is 12 inches, right? And the base over here is 15 inches, okay? So what we want to do, I think, is find, it says, what is the height of the sail on the real boat? So we're looking for this. So we're gonna set this up as a ratio, okay? So we're gonna say x over 12. I'm doing side to side, okay? Y'all see that? Equals 25 over 15, okay? So we're just gonna cross multiply here. So this can be 15x equals 12 times 25. So 15x is equal to 300. And 15 goes into 300 20 times, right? So x is equal to 20 here. So that's the answer, 20 feet, okay? So next one says, use the information in the figure. So for both 37 and 38. So it says a spring is attached to one end of the support and the other end to collar A, as represented in the figure. Collar A slides along the vertical bar between C and D. The figure in the figure, angle theta is the angle created by the collar as it moves between points C and B. So we see that theta right there, that's an angle measure. And then from B over here to D, that distance across there is 3 feet. Okay, so it says when theta is 28, so let's go ahead and put our 28 in here, degrees, okay. Which equation can be used to find the distance from point A to B? So now let's relate these sides to the angle. So it's asking us for A to B. So it's asking us, if we kept it going across here and drew this line, there would be a right angle right there, right? So this is going to be our hypotenuse, yes? And the 3, because it touches the angle, is our adjacent side. So what ratio uses hypotenuse and adjacent? That would be cosine, right? So we're going to say the cosine of our 28 degrees is going to be equal to our adjacent over our hypotenuse, and this would be our variable, right, x. So our adjacent is 3 over our x, okay, so it's cosine of 28 equals 3 over x, so that would be C, okay. And we're going to use the same figure for the next question. So it says, and I'm going to talk y'all through this. So it says, when the spring is stretched, the distance from point A to point B is 5.3. So now we're going to say that this is 5.3, okay? So when we do that, it's asking us, what is the value of theta? So now it's asking us, what is the angle measure? So now we don't have the angle measure. So we're still going to have adjacent and hypotenuse. So we're going to do an inverse cosine, okay, to get this angle, okay? So, so we're going to say the cosine, the inverse cosine of the adjacent, which was our 3 feet, now over our hypotenuse, which is 5.3. Put that just right in your calculator, and it's going to tell you that the answer is 55.5, okay? 55.5 is your answer, okay? All right, number 39 says the degree measure of an angle in a right triangle is x. So if the sine is 1/3, which of the following expressions also is equal to this 1/3? So if we had a right triangle here, okay, and it said the sine is 1/3. So if we were trying to talk about this angle A up here, for example, so if A was the sine is equal to 1/3, then that would be opposite over hypotenuse, right? So now if we're trying to talk about the cosine, what would be the cosine of the same value, then we'd have to be talking about this angle down here, wouldn't we? Because cosine means adjacent over hypotenuse. So we're talking about these two angles, and here's my question for y'all. What do these two angles have to add up to be? They have to add up to be 90, don't they? So if we have the sine of one angle, x, then the cosine of the other angle would have to be 90 minus x, wouldn't it? Because those two angles have to, so x plus 90 minus x have to equal what? 90, okay? And these two cross each other out, so 90 equals 90, okay? So that's why the answer is the cosine of 90 minus x, okay? Remember that these two angles have to add up to be 90. All right, number 40 says an object dropped from the top of the Leaning Tower of Pisa 17 feet from the base. So there's your 17 feet. Which of the following equations would be used to determine the angle that the Leaning Tower of Pisa is with the ground? Now, mind you, this would be inverse, but it would still be this equation, right? So we have the adjacent here, and this is our hypotenuse. Again, see that because it's opposite the right angle, right? So adjacent and hypotenuse are cosine, so it would be the cosine of x is equal to the 17 over the 179, right? Cosine of x is equal to 17 over 179. Okay? This one says an airplane makes a 15-degree angle of elevation. So that's going to be right here. So we're going to redraw, okay? From the runway as it takes off. The airplane is shown as 2,000 feet along the ground from its takeoff point. So that means this is 2,000 feet right here. At what height is the airport? Is H is the airplane. So this is what we're solving for, right? So we're going to say this is our opposite, right? This is our adjacent. So we're going to use the tangent ratio. So we're going to say the tangent of the 15 degrees is equal to x, opposite, over adjacent, 2,000. Remember, if we have a number in the denominator, we're going to multiply both sides by it, right? So we're going to multiply both sides by 2,000. And so this is exactly what we're going to put in our calculator. And when we do, we get 536 feet. Okay. Here's our last question. A pole has two wires attached to it, one on each side, forming two right triangles as shown. How tall is the pole round to the nearest foot? So it's actually asking us for this right here, right? So I'm going to put our X right there. Okay, so we're going to say, again, this is going to be opposite, right? And this is adjacent. So that's the tangent ratio. So we're just going to say the tan of 41 is equal to x over 34. And again, how do we get rid of that 34? We multiply both sides by 34, right? So you're going to put that 34 tan 41 directly in your calculator, and that's going to give you 30 feet, okay? So our next one says, how long is wire A? Or wire 1, sorry. So if we're looking for this wire right here, we're going to use another ratio, okay? So if we're looking for that wire, again, this time I'm going to use adjacent and hypotenuse. Isn't that our hypotenuse? Adjacent and hypotenuse would be cosine. So we're going to say the cosine of our 41 is going to be equal to the 34 over our h. I'm just going to call it h this time, okay? So this time we swap the h and the cosine of 41. So h is going to be equal to 34 divided by the cosine of 41. And again, you can put that directly in your calculator. And when you do, it gives you 45.05, which means the answer is 45.